Good morning, good afternoon, good evening, and good day, everyone, and welcome to the IS-BAO Progressive Stage 3 Roundtable. Today's topic, as you can see from the slide, improving safety through aircraft health monitoring and predictive maintenance. Before we get started, I've just got a few housekeeping items to go over. The attendees you all are on mute because of the size of the audience. However, I want to point out that there is a questions block in your control panel for the GoToWebinar. Feel free to type in any questions you have at any time during the presentation today, and we have time reserved for questions and answers after the end of the discussion. So please feel free to do that. I would like to introduce Andrew Karras, the IS-BAO Program Director, to give us some information about PS3 and IS-BAO and to kick off the program here today. Andrew.
Hey, thank you, Catherine. I appreciate kind of the introduction, the housekeeping items. It's a pleasure to host another IS-BAO Progressive Stage 3 Roundtable today. Real-time data from aircraft components are essential to increasing aircraft safety and reliability. The integration of aircraft health monitoring systems is expanding within aircraft manufacturing processes and are crucial to decreasing inspection times and cost to operators. Moreover, regulators are now providing guidance to support the integration of this technology in order to increase safety within the airspace for which we all share. We're excited to introduce this topic and welcome you to the Progressive Stage 3 Roundtable today. I'd like to welcome our guests from Bombardier, Dassault, and Gulfstream Aerospace. Additionally, I'd like to thank Blair Robson, who is volunteering his time and safety expertise to moderate this panel. Again, thank you all for attending, and I hope you enjoyed the discussion. Back to you, Catherine.
Thanks, Andrew. I am very happy to give a little bit more introduction on our panel members. As Andrew mentioned, Blair Robson, he's the manager of aircraft maintenance and aviation facilities for a large Texas-based flight department and has been instrumental in many of these PS3 roundtables. So thank you for that, Blair. I also want to note that with connection issues and all of that, Blair may be talking without having his camera on so that there's not a lag, so just so you all know that. Nick Kershaw is from the Gulfstream Aerospace Corporation, the project development team lead, and his computer has some camera issues today, so he will also be a voice. On camera are Jody Curtin from Dassault Falcon Jet. He's system specialist in electrical, and George Topeus, did I say that right, George? I should have asked that ahead of time. Yay. George has had 20 years of experience in business aviation services and is currently the lead customer engagement for SmartLink Plus at Bombardier Aviation. Thank you all so much for being here today. I'm really excited for this topic. And Blair, I'm going to hand this off to you. You can tell me when you need the next slide. And thank you. It's all yours, Blair.
Perfect. Well, welcome, everybody. I hope we spend a good part of your hour talking about a future project. So I want to make sure that we talk about that this is all happening in the future, not today, but hopefully after this discussion, you'll have a good excitement for what's hopefully happening in the future. So we're going to talk about, Catherine, can you go to the next slide, please?
That the one?
There we go. Thank you.
Yep.
Okay, what I'd like to do is this advisory circular came out in July of this year, so it's pretty new. I want to kind of put this as our baseline or of our set the stage, if you will, for our discussion today. So I'm not going to try to read the slide to you, but I want you to see that basically at the end of the day, we're talking about setting a stage for integrated aircraft health management and what that can do for the terms of predictive maintenance and be able to better monitor the performance of our aircraft. The audience for this particular advisory circular, as you can see, is for 91, 121, 125, and 135. It does not mention 91, even though I'm a 91 operator. This is still something that I'm looking forward to in the coming years, that's for sure. Next slide, please. Okay, as we know, if we've read advisory circulars before, there are certain sections, but I picked out the ones that make the most sense for us today. Airworthiness determination. For the purpose of this advisory circular, an airworthiness determination is made by using certified for credit, integrated health management systems data, and displayed status on a sole source to determine if an aircraft's root system is in condition. So a lot of definitions go through first. Certified for credit. As you can see, it gives design approval for a system, adds to, replaces, or intervenes in an industry accepted maintenance practice currently performed by parts 65, 121, 35, and 145. So we're talking about our MELs, we're talking about our DDGs, we're talking about those type of things. As we know today, is we wait for the part to break and then we approach it accordingly. But this is talking about, again, in the future, not today, how we can change or take this to the next level. Next slide, please, Catherine. The root system. What is that root system? It can be anything. In this case, they picked the example of our aircraft landing gear system, benefiting from the tire pressure information from that system. The background. So we've all heard about hums, we've all heard about health and trend on our engines, all of this. So I bolded this to make sure that you understand it. Yes, there are some things already in place, and this advisory circular is not intended to mandate a name change in these cases where terminology is proprietary or has commercial value. So we're tying all of these into one program, is the point here. Next slide, if you can. So what's the concept? What are we trying to do? Comprehensive integrated aircraft health management is an end-to-end concept that encompasses aircraft systems, data transmission, and data analysis and implementation, often on ground-based equipment. What is ground-based equipment? It can be the computer that you may be sitting at today. It's been able to do analysis of your aircraft from your office environment to make decisions about safety of flight. And that's the ultimate use of this process data, is to make decisions pertaining to some intervention action or provide data to other processing means to make the intervention action determination. So big words, but next slide, please. Here's the program. So the FAA has already given us the roadmap, if you will, for what the program will need to have in order for you to RTS or to MEL or the DDG your particular aircraft. So you can see there's quite a process. You got to gain authorization. You got to do a lot of training. You got to have the right aircraft with the right equipment in it, using MEL procedures for missing parameters, data transmission compliant, data security, and of course, use of this system in an approval of maintenance or inspection program adjustments. So we'll talk about that here in a second. Next slide, Catherine. So they gave you some examples in here I wanted to point out. Here's some examples. Verifying system functions instead of gaining component access and testing for troubleshooting. What does that mean? That means that we'll be able to see on our website that is hooked into the airplane before we don't have to go down to the hangar floor to see what's going on. We can do it from our computers. Oh, next step, performing a dispatch deviation guide procedure for MEL relief. And then what is a program escalation example is to escalate or de-escalate a scheduled task based on the aircraft's, the MRVR that recognizes the health and trend alternatives following the guidance. So what does that mean? That means that if we see that a particular component is failing far faster than what Chapter 5 says, maybe we have the data now to say we need to move that item forward or move it to the right. Maybe we don't need to do it as often. So this is what this data can do for us. MEL, interaction with the MEL process is twofold. As you can see, the first consideration is how fully a functioning system can be used in MEL deferral of another aircraft system. In case the deferrals, and it says, see the paragraph, this is that paragraph. The decision approval holder, which is the OEM, may provide for the use of that system for MEL deferral, a maintenance action in the DDG or aircraft maintenance manual. The second consideration is how the partial or total loss of that system should be included in the host aircraft's master MEL. And they already have a listed OPSPEC D302. So it could be an LOA or an OPSPEC in D302. So with that said, next slide. Okay, so now we've set the table for what this future system looks like. It can do many things for us. It can sit there and allow us to, and we'll get into an example here after these three gentlemen talk, is how can we dispatch an airplane with a known issue in the cockpit of a CAS message, but using the data back in our office, looking at this airplane with a certified airplane and a certified system and a certified training to allow us to go flying. How can we make our airplane more dispatchable friendly? So with that, I'm going to leave it off, and we'll start with George. And George is going to kind of introduce what Bombardier has an approach for this particular idea. And then we'll move on to Jody, and then to Nick, and then I'll come back in.
Thank you, Blair. Good morning and good afternoon, everyone. First, I'd like to thank IBAC for organizing this webinar, and for Blair, my fellow panelist, for agreeing to moderate. AHMS, or Integrated Aircraft Health Management, is very important at Bombardier. It forms the centerpiece of our service strategy. So everyone can get a sense of where we are right now. The surface level is our HMS system, SmartLink Plus, allows you to connect in real time with your aircraft and track its performance. It provides data for analysis, so it can support maintenance decisions. We also use it as a platform to automate what are currently manual tasks, and we have a security infrastructure that we place all the aircraft data behind to keep it safe from unauthorized access. My focus today, what I'd like to achieve is a better understanding from an industry perspective of, when we refer to aircraft maintenance aircraft health monitoring, or integrated aircraft health management, so we're not talking cross purposes, what it means, sort of framing the discussion. Over the course of my last year in this position, my current position as leading customer engagement for SmartLink Plus at Bombardier, I've had to grapple with essentially four concerns, four recurring themes from customers who want to know about the implications of employing aircraft health monitoring. The first one is the big brother issue, right? Will the OEM be peering into my operations? That is an absolute no. I think I can speak even for my fellow panelists from the other OEMs. That's not the intent. The objective is to employ connectivity and aircraft health monitoring in service to our customers. The second issue is the privacy issue, right? Customers seem to conflate privacy with security. If you don't know where I am, or if you don't know my times, for my destinations, then I'm keeping my aircraft safe, my aircraft data safe. That's incorrect. First of all, in an ADS-B environment, privacy is an illusion. We are more geared towards talking about, or it serves as an industry, better if we're talking about security of the data. And HMS or integrated aircraft health management services do exactly that. They secure the aircraft data that you're not exposed to unauthorized hackers or unauthorized access, such as hackers. The other thing is the misconception is the ownership of the data, that we're leveraging data that's not ours and making the customer pay for it, which is another misconception, right? The aircraft data that resides on the systems, on the aircraft systems, is entirely 100% owned by the aircraft, the customer. But allowing us to take that data and synthesize it and putting it through our systems, our HMS or integrated aircraft health management system, allows us to refine the data and present it back to you such that it provides some actionable intelligence or guidance to help you better maintain or operate your aircraft. So that is the IP that we are selling. And finally, and Blair touched upon it several times on his intro, is that the AHMS technology has far surpassed the way we do things, operate from an operational perspective. And I think there are many gray areas that we can't all solve in one fell swoop. As an industry, we need to come together and make sure that we populate these gray zones and make sure that we have standards, that we have regulation where it's warranted, so that we all know we're all playing from the same playbook. That's my introduction, Blair. Back to you.
Well, thank you very much, George. I appreciate everything that you said, and looking forward to more discussion here in a minute. Jody, the plate is yours.
Hi, everyone. Jody Curtin here. I work for, as you can see, Dassault Falcon Jet, but I've worked there for almost 10 years. My night job, if you will, is another organization I represent as president, which is called the Westchester Aircraft Maintenance Association. It's really based, it's an East Coast organization. I know a lot of you are not from this area necessarily, but those of you who are recognize WAMA, and WAMA recognizes and supports and represents the aircraft maintenance community locally in the tri-state area, but our arms go pretty far out into the U.S. I think we're probably, well, actually we are one of the oldest maintenance technician organizations in the country. We had just turned 60 years old in 2 years ago, 2020. We didn't celebrate it, obviously, because of COVID, but we're still celebrating, let's say. So we're 60 years old. My work experience, I was a flight tech and an AMT for over 15 years in a large corporate flight department. And I now work for Falcon Jet in Teterboro, New Jersey. So I'm on the other side of the fence. I was a customer for many, many years. Getting into the industry and the need for safe airplanes and predictive maintenance and assisting technicians and customers with maintenance issues on the airplane itself. I'm just going to go into a little bit of the model history of the Falcons and the models. We started out with, of course, the Falcon 20, and then we had the Falcon 50, and today they're actually called classic, the classic models. So with the classic models, there really was no health monitoring, if you will. There was no predictive maintenance. Basically, there was tests on components in the airplane during the design phase and working with the manufacturers of each of the components to say, how long each component would actually last on the airplane, and then design a maintenance program around how often a component needs to be changed, inspected, and things like that. So the very first set of models, Falcon 50, Falcon 20, early 900s, really had no predictive maintenance philosophy behind it necessarily. By the 50EX, a little bit later on the 900, 900EX, and then we'll be talking about the EZ in a second, they started coming out with more predictive tools, basically. The first was really engine monitoring, so trends on engine operation through Honeywell and or Pratt & Whitney at the time. But you would have to download these, you would have to have tools to download it, and we could not actually analyze what was going on with the engines. We had to actually send them out and then get it analyzed, converted, and then the information sent back to us to know exactly what we wanted to do or what the engine manufacturer recommend that we do. From then on, it went into it moved to the EZ around late 80s, early 90s, mid 2000, early 2000s. The EZ EPIC system made by Honeywell was coming out, and now we had a chance to actually design a little bit more diagnostic tools around that, because everything became digital. Digital leaves crumbs. Crumbs can be recorded and be used for diagnostics and predictive maintenance a little bit more. I wouldn't say predictive maintenance, I keep using that, but diagnostics in a way that we could maybe zero in a little bit more on what the component failure would be. This added to the safety aspect, but it still wasn't completely, I won't say not useful, but it wasn't a complete troubleshooting tool completely. We still had to how to analyze, we still had to use intuition, and we still had to use, converse with the OEM and or the engine manufacturer to go a little bit deeper. It saved a little bit of time, but still, it's not going to point you exactly to the component that you're actually that was failed or need to change. With the EZ system, it became somewhat as the pilots now were involved with how the airplane behaved as far as diagnostics. So we had CAS messages, and CAS messages turned into being able to find out what the maintenance messages are, and then the maintenance messages were then converted to ways to find out exactly out of 10 areas, maybe narrow it down to 2 or 3, and then of course you might have to do a little more troubleshooting. So it was getting a little bit better. The EPIC system used what's called generic input-output boards, which that's what the basis of the CAS messages and the maintenance messages were. So as a diagnostic tool, which could be downloaded, it was shareable to the command center, to the technical center, or the customer, or if you were someplace where you couldn't get help, at least that information could be, the data could be sent to places where it could be. It all started out with, the basic central system is called the CMC, or the Central Maintenance Computer. From there, all the diagnostics happen, and with something called the FHDB, or the Flight History Database, can be downloaded, and this is the data I was talking about. We had something to help the crew on dispatch a little bit better, called Falcon Broadcast at the time. And this is not a plug for anything on the Falcon side, but these are the tools that this OEM started to see a need for. And before the airplane actually arrived at the destination, a broadcast of the active failures could be sent to anybody through email. This then helped on the other end, maybe get parts to a place, or maybe a little more troubleshooting could happen, hours before the airplane actually arrived. Then we come into the next phase, which of course is the next airplane, and the airplane I'm talking about is the 6X. It's the first airplane that's actually designed around health monitoring. So the basic fundamentals of it is called the MMS system, which is the multi-purpose maintenance system. and it sits alongside the original CMC EPIC system, but the EPIC system now is not used for trend monitoring, the MMS system. And basically, it's just a web-based interface for technicians to dig even deeper, because now we're actually working with vendors of components that are designing the components with this predictive maintenance or health monitoring in mind. Before, it was just you've got a black box and the wires go in and it talks to a board that happens to be saying yes, it's working, or no, it's not working, and then these are the fault codes. Now each vendor that we're actually using is designing the component to work integrated with the airplane such that this MMS system can work the way it should. Again, it won't tell you exactly, but it can give you a little bit better with bit codes and things like that. So you obviously have to understand how to read it, how to interpret it, and then go from there. It's called Falcon Scan, and Falcon Scan is the interface between the technicians and the airplane itself. But the MMS system is the heart of the nerve center of the predictive maintenance aspect of this particular airplane. It does not take the place of dispatch. You still have to use the MEL or the MMEL. That determines your dispatch. And this is just basically a very integrated maintenance tool for the airplane itself. But again, you still have to decide if through the MMEL if the airplane is dispatchable or not. It records all the digital buses. Like I said, it helps in the troubleshooting. It can be used to load software and databases in the airplane, so it's very centralized. And it is cyber secure. So we were talking about security and things like that. Because it uses a Falcon database and the application is on a laptop that's secure, there are a lot of cybersecurity measures in place with this system. It's, again, all web-based technology, and it uses a LAN, so it's Ethernet-based, so it's very, very simple. That's all I have. That's where we are right now with the 6X. It's the latest airplane it's an airplane that's designed around MMS or health monitoring systems. So thank you for listening.
Thank you very much, Jody. Great presentation of what the future is at the SO. On to Nick Kershaw with Gulfstream. Nick, you have the floor.
Thank you, Blair. Good morning and good afternoon, everybody. My name is Nick Kershaw. I am a product development leader over here in Gulfstream. We work in the flight deck innovation side of the house, which means we're on the advanced programs side of engineering, and we get involved in a lot of the future technology, and we also get involved in some of the incremental improvements to existing products, as well as some of the services that we could create around them. And that's really where I got involved, and I'm relatively new to the data side, probably been involved for a couple of years now. I think I would echo what George said at the beginning. This is a very interesting topic, and I hear a lot of the same concerns from customers that George, that you expressed. We hear a lot of themes around security and ownership, yet there is a definite increase across business aviation in the use of data that's captured on board the airplane, and indeed even the data that's captured off board to provide context, maintenance information, other things, operational data that's captured. In terms of Gulfstream, we have approximately 700 aircraft now that are equipped with data systems, which collecting a lot of parameters, tens of thousands or so. The first airplane entered service in about 2012. I think, Blair, you have 650. That was the first airplane that we delivered the system with. So we've had a number of years now to get acquainted with the information that we're capturing, and I would say that overall it is a significant challenge. And I would say that, you know, again, echoing some of my counterparts of the other OEMs, we've had a lot of interest in a lot of success from the engine health side, and indeed on the Fokker side in the flight ops quality assurance programs. But when it comes to things like predictive maintenance and the gold standard of, you know, of being able to find a impending failure, I would say that is a significant challenge. Now we're, you know, investing heavily in that area, and obviously having access to the data for over such a large period. We've used it extensively to help improve reliability, to drive changes in the supply chain, to catch errors before the airplanes deliver, before they enter service. So it's, you know, it is an extremely successful program for us. It is very very useful to us as a company, and I think it's very useful to the customers. I would say, you know, in all being transparent, you know, and Blair, I think you probably agree. It's very difficult to provide a direct value to a customer by having them consume their own data. And I think this is where this AC comes in, is that it gives us an opportunity to now allow the customers to consume their own data and the operators to consume their own data and make decisions based on that data. In the past, certainly early on, it really all had to come through us as an OEM for analysis before we could provide direction on which way to go. And I think if I'm understanding the intent of this guidance correctly, I think where we're going is towards providing these services behind the data that allows customers and operators to make their own decisions and their own operational plans around this information. So, you know, we're kind of moving down a path of trying to develop these services, and, you know, obviously everything comes down to, in our minds, probably 3 use cases. The primary one being safety, and then there's kind of a reactive aspect and a proactive aspect to it. The safety aspect is, you know, we want to improve the reliability, we want to improve the dispatchability, we want to improve flight crew training, we want to improve prevent maintenance mistakes. You know, data can be leveraged for any of those in a safety aspect, and there's probably a few I'm missing. In the reactive sense, it would be, you know, highly useful, as you described, Blair, to be able to look at the data and decide exactly what is failed without having to inspect the airplane. Especially if you're going to, you know, perform some work, it cuts down the time that the airplane is on the ground. It cuts down the time of return to service. And then the proactive side, really the gold standard of being able to predict something failing. A very interesting topic, you know, obviously highly successful in the engine space, really anything mechanical. You can detect deterioration in performance, something doesn't move as fast as it used to, something is leaking, something doesn't maintain the right voltage. You know, there are many ways that that you can look at that and start making predictions, but it's difficult to really make that work, because you end up in a position where there's a level of confidence that might be, you know, 75% confidence, and some people don't want to take that chance. Some people do want to take that chance. So the proactive part is, really where we want to go, but there are several steps to get there. I think the safety aspects of it are extremely compelling. The AC here providing some guidance around the reactive aspects to it, and then of course the proactive to us is the gold standard. So we're moving down that path, and like I said, investing in the services and the capability to make that happen. And we look forward to it, and we think it's an exciting prospect. And I do appreciate the invite to talk today. Thank you, Blair, and to the IBAC team. Blair, I don't have anything else. I'm just going to hand it over back to you.
All right, thank you very much, Nick. I appreciate all that great information. Catherine, if you can go to the last slide, and we can kind of center our rest of our hour on these questions that I kind of posed at the end to make sure that we discuss these so you can kind of look at them. So let me just kind of give you an idea of, Nick is absolutely right. We were very fortunate to get the first 650 with the health and trend monitoring system built into the airplane. Besides, just the engines, it did have it on the airplane, and I was fortunate enough to be taught how to read that website and how to gain information from our aircraft while I was sitting in my office. And when we started operating that airplane and using that system, I was able to, believe it or not, troubleshoot, isolate, and decide what part to fix before the folks could even get the ground power set up on the airplane and start looking through it through traditional methods, through the CMC and things like that. I did that twice and I was very impressed. They were kind of like, how did you do that so quick? So with that in mind, that's what I'm looking for and now that we see there's an advisory circular built for that type of thought, how are we going to, one, I think, it starts with the OEM. It starts with the design authority holder, and if as Jody talked about with the new 6X, about going out to the vendors of each of their components that make up the airplane and the systems, to sit there and tell them that we're gonna spec that component so it does talk to our main system on the airplane and then relays that information. I think the other point that's important to talk about is one is believing in the system. Obviously, it is a thought, it is a advisory circular, it's pieces of paper, it's words. How does it look when you do when a new operator does take delivery of this 6X or whatever a Bombardier product or a Gulfstream product? Will they be taught, like I was way back in the day, of how to use that information, how to use that knowledge? And then I think even more importantly is that it's taught back to the people in technical operations. When you do make that call back to any OEM, and that OEM does have your information and is looking at the same information you are, without saying, oh, just send me a fault history database and I'll let you know. Well, that takes time. It's not, as we all know, when an airplane is AOG, time is of the essence. And if we can eliminate those kind of transactions, if you will, and look at things in live data, can we make a decision to either go fly the airplane if the MEL is incorporated with this system, make a DDG determination? One quick example I'll talk about is, it doesn't matter what kind of airplane it is, but it talks about, let's say if you have a pressure switch that has one job in life, and that's to drive a CAS message that says my hydraulic pressure is low, but we see on the synoptic pages that the pumps are running, the flow is correct, you can move everything you need to do with that hydraulic system, but you have one switch giving you an amber CAS message and you're done for the day. How can we use that system, that knowledge, this way of looking at the airplane in live time and say, And if the MEL is written this way, it's okay. We understand that there's a switch that's telling you something, but we tell by our live system and by what we see on our synoptic page that we're allowed to, again, and this is all future stuff. I don't want you to think about this as today. Future ideas of how can I dispatch this airplane? We're all in the business of making airplanes fly. How can we take a little tiny switch and turn it into something? Yes, we'll get a new switch coming. Yes, we'll do all the right things, but how can we let those pilots fly that airplane? So that to me is a goal, one goal of it. The other goal is this. Let's say we're flying and we're halfway across the world and we're looking at our airplane in live data, and we see that a particular component, whether it be a valve, whether it be a monitoring system, whatever it is not doing too well. It's not feeling good. We have a low tire, as the AC talked about. How are we going to be able to not only in the direction of, let's say we go flying, but sit there and make a determination, a solid determination based upon the facts of, I don't think we should fly. Even though it feels good today, you get up and go and flying over the ocean is not the best plan. Not the best plan based upon the data, live, true data that we're seeing from the airplane. Yes, you don't have a CAS message. Yes, you don't have this. Yes, you don't have that. But we do not have confidence in that particular part. So it can go the other way. Another thought to think about as well is, as the AC talked about, let's say that Chapter 5 says we're going to change this every 500 flight hours, and we're finding through the data given through the fleet that 500 hours is too quick, way too quick. How can we convince the FAA that, look, and as you can see in that little bit of AC that I showed you, that you could make a point to say move it to the right, move it, let's say maybe to 750 hours. So there's that idea. And let me wrap up with this, and I'll hand it back to the gentleman to talk about, is with all of this said and turning in parts that are not quite broken yet, the whole system, the whole parts repair organizations, everybody has to be on the same page that says, I brought a part that my data shows is about to break, but it's not broken. And the last thing I want to do is introduce more parts to the no fault found program, and somebody else gets it and ends up having that issue. So we all have to believe in the science of this to follow it all the way through. But at the end of the day, as you can see, I'm all about how can I make my airplane fly? How can I make more intelligent decisions about my airplane so that I can keep it flying if necessary, or not fly if I see a safety of flight issue based upon the data. So with that, I'm just going to leave it back to whoever would like to Nick, Jody, or George. What do you see? How far away are we? Are we 3, 4, 5 years away, or is this something that that you have that you can't share right now because of proprietary issues? What do you see? 3, 4, 5? I'll let open anybody would like to answer.
Well, I guess I'll jump in. So Blair, I think that there are aspects of this where you could say we could do it today, right? And really, the airlines do it today in some respects. I don't know, George, if you're involved with perhaps maybe the airline side from Bombardier, but being able to monitor some critical systems, certainly mechanical systems, for degradation in performance, and then make a decision on whether you want to dispatch, like you said, Blair, and go across the Atlantic, or go on a 3-week trip that has multiple stops away from home base. I think that stuff is pretty close range. On the other end of the scale, I think potentially where you've got try and mitigate or work around an MEL, I think that's going to require more deep design change or design consideration up front with the LRUs, with the system architecture on board, such that the monitoring system, which is not the primary monitoring system, you know, like a CAS message, for example, has enough integrity that you can believe it to say, yes, even though this thing has happened, we can look at this data and you can get temporary relief from it. I'm not yet sure how we would, you know, how the industry on the whole would accomplish that. Just because, you know, the MMEL is the MMEL. That's further away. I don't know that I could put a time frame on it, but I think, you know, I think it's a great way to look at it, and it's a good target to aim at. But like I said, I think there's definitely some aspects which are short and nearer term.
Right, thanks, Nick. Go ahead, George.
Sorry, Blair. I was just going to agree with Nick's assessment. I think as an industry, we're not there where there's a steady drumbeat of predictive guidance emanating from the OEMs to the customers. But on one of the points, I'd like to add one of the points you made earlier about the no fault found reference. I think as an industry, here's a very good example. As an industry, you know, if we're going to be employing predictive maintenance AHMS systems in that regard, you know, to that end, we as an industry have to be ready. If the systems are saying that these parts haven't failed yet, but they clearly, from what we see through our data visualization apps or interface for our HMS system, they're clearly operating out of you know, normal specifications. I think as an industry, we should take that at face value, have the customer be able to return those parts to the OEMs with no fault found, you know, charges, and then we'll take them, you know, bench test them, recertify them, or scrap them based on, you know, our assessment, and then move on. You know, customers do not want to be hearing. We cannot speak out of both sides of our mouths. We can't say, well, look, we you know, in the past we had no verification, you know, ability. It was only after the fact. But here, if we're gonna, as an industry, speak to the criticality of employing HMS systems, then we have to be ready to stand by that assertion. And I think this is a good example of the no fault found is a good example of that commitment to it.
I think both are correct. I think we're on the right path and the right direction of wanting to be more, you know, to have more predictive capability. But I don't know. You said 3 to 5 years. For that to happen, every single airplane would either have to be retrofitted, and many can't. In the case of the 6X and the MMS system, this is not a retrofittable system to a previous model. So every airplane that's flying today, if that's the direction we want to go, every airplane has to have some sort of ability within its components to speak to or communicate to the MMS system or to the health monitoring system, for everyone to be on the same page. So there's going to be airplanes, there's going to be classic airplanes that don't have it. There's going to be new airplanes that are designed around it that do have it. What we can't lose is the ability to troubleshoot. And I think we're seeing that a lot now. If there's too many tools, well, the thinking is if there's too many tools and too many crutches, we will lose our A game when it comes to troubleshooting. It's already the case. We have, you know, the Chapter 20, we have the AC 4313 to guide us in areas where we don't have a task for every single item in the airplane to be replaced. So sometimes you have to rely on your AMP or your AMT skills or your A&E skills to be able to do the work. So there's no substitute basically for good troubleshooting. There's no substitute for intuitive thinking. We'll never not need it. We'll always have it all the time. But as far as the health monitoring and the safety aspects, yes, it will. We can catch things earlier than we have, and what that'll do is maybe save money on changing shotgunning parts, if you will. But going back to the no fault found, that's a really good point, because we're struggling with no fault found items. Vendors just can't turn a no fault found or an unknown condition component around that fast. So we are already having logistic issues, parts shortages and things like that. The last thing we need is to have parts that are removed from an airplane that we just guess that it was failed. Then it goes through the repair process, waits in a warehouse to get shipped out to the OEM, to the vendor. The vendor only does the inspection and the ATP only to find out there's nothing wrong with it. It sits there, it gets shipped out again, and then that whole process. And nobody wants a no fault found 8130, and so of course they're going to be looking for a new one, or one that was repaired with a definite problem on it. So we'll always have those challenges also. I don't know that this HMS philosophy will eliminate that at all. Maybe a little bit, but again, you'll really have to know how to interpret the information that the health monitoring system is giving you. So that means you have to be, training has to be there as also as well. You could have fault codes, bit messages. You have to read them and interpret that. If you have two of these, that means it's not a problem. If you have one of them and maybe another one, so you have to find a common fault that would point to a particular item, and then you have to test the item to make sure that that's the that the HMS system was correct in its assertion of the failure. We'll get there, maybe not in 3 to 5. Like I said, not every airplane is going to be able to have it by that time. Every component out there still works and is not tied to a central monitoring system. So until that happens, it could be years.
Jody, I appreciate George and Nick. I appreciate your responses to my many questions there. Catherine, back to you. Is there any folks out there that like to ask a question before we wrap up this hour?
Yeah, thanks, Blair. One of them is a question about subscription costs for receiving AHM data. Stand by, I have to move a window from the aircraft, say, versus other modes that you're in now.
I know that I can kind of answer that for the Gulfstream fleet. Yes, there's a subscription cost. Don't quote me exactly, but it's about $5,000 a year per airplane. But as you can tell, I was trained on this, and again, Jody made a good point about using your fundamental skills of troubleshooting and all of that, and trying your best not to shotgun or anything like that. But yes, the quick answer is yes, there is, and it's about $5,000 a month. But if you are trained to use this system, it is definitely not the only place for you to go look for how to troubleshoot, but it definitely does, as you could tell, it's very successful in pinpointing the exact component in that system that is causing that issue or driving that CAS message. Well worth the time, effort. 5,000 was it paid for itself really quickly, being able to troubleshoot. But again, I totally agree with Jody. Is you can never forget your fundamental skills of 4313 and the basics of troubleshooting and trying your best not to shotgun. Next question, if there is one.
Yeah, hey Blair, I'm jumping back in. Andrew here. I appreciate it. We have another question from the field. Interested to know, based on that question, as well as your experience and the OEM collection of, statistical data, how much could this system save an operator with regard to maintenance costs and, troubleshooting a fault? Relative relative to the subscription cost. It kind of, Blair, if you could share your experience, and maybe George, Jody, or Nick, if you have anything to kind of add on that as well, that'd be great. Thank you.
I will take the money savings aspect and translate that into availability of the airplane. If I can make my airplane 100% available and dispatchable, that is my #1 goal in life, is to make sure that airplanes are always available if they're not into a scheduled maintenance events or anything like that. Give you a great example today. Last night our airplane came back with a cracked pilot windshield. If there is a magic ball out there that tells me that my windshield is about to have a heat stress crack, oh boy, wouldn't that have been great if I had a windshield sitting here as they came in, but I don't. So I'm scrambling to get myself a windshield. So again, the money savings of having that windshield there, not paying for the expedite cost, not paying, now that I know I can get some folks in to help change that windshield, I'm not paying for extra support teams to come in, all of these things. So the savings is a per scenario basis, but I think $5,000 will pay for itself rather quickly if I knew ahead of time that my windshield was about to break.
And Blair, I don't, wanted to add to the answer to the previous question. Subscription costs at Bombardier start at $10,000, and that's a fully burdened subscription rate. But we have a plan to retrofit the entire wide-body fleet, approximately 3,000 aircraft, and we are providing the box, the HMS box, and the associated wiring, covering it entirely free under Bombardier service bulletin. So I just wanted to answer, I wasn't ducking the question. I wanted to make sure that was said. And second of all, the other point is on how much you can save. Anybody that comes on SmartLink Plus, the costs associated with the subscription are more than paid by the service features and the value that it provides. Two cases in point. We had a charter revenue flight where there was a CAS message that was raised, and it took within minutes to confirm when the customer called CRC to confirm that this was a sensor issue, and that there was nothing wrong with the system that was being triggered with the CAS message. So there was, I'm sure, $250,000 charter trip that was saved, that was close to be AOG. In another case, we had a multi-leg, a customer going with a multi-leg flight that was going east to west and then on to Asia. They had a CAS message that was raised, and we were able to troubleshoot and diagnose the issue as being as potentially requiring a part switch out. And we had our Chicago parts center drop ship a part that was ready when the aircraft landed, and the customer was able to keep their Asian leg, to execute it. So the answer to Andrew's question is that they could be sizable from an operation standpoint, right? But even with that, there's a multitude of tasks that are automated by HMS systems, services that are currently done, manually. There are many tasks where you currently need to dispatch a technician to the aircraft that needs to extract the data and then transfer it over an open line, over an open network. And with SmartLink Plus specifically, you don't have to do that anymore. It's all done on the back end automatically, totally a passive system.
I think with that, our hour is up. I'll leave it back to Andrew and Catherine.
We of course now we're getting more questions in. Just one quick one, if you all have time, in terms of how does this improve safety for your operation? It's a longer question, but with this one question, the as an active A4A MPIG member, we've installed a drive to move from MSG3 to MSG4, a paradigm shift. We've talked about commercial and regulatory aspects, but what are the consequences on safety? So any thoughts on that?
I'll jump in there real quick. Again, my example of having an airplane, let's say in a multiple leg around the world trip, and being able to watch it, that data live time. And if we decide that the next leg is not advisable based upon the data and based upon the conditions of that particular component, then that's where, I mean, predictive maintenance can halt that flight or stop that flight until we get the right component in. So to me, safety of flight is of course paramount, and everybody's, that's the number one thing, is safety is first. Nobody gets hurt. There's my plug for the company. But anyway, at the end of the day, this system can be used for safety related, and that's what we're all about, is the safety, is prevent that next leg from flying if we know that something is not gonna be a good day for that flight. And that's where, I mean, safety really plays in well, if we know the information and have access to it and know how to read it.
Awesome, thanks, Blair. And any thoughts from the others?
Well, we have actually the next generator actually from Thales on the Falcon, on the Honeywell 731s. They just started using, or a couple of years ago, they started coming out with a, when you're talking about safety, instrumented brushes for brush wear. So that's already a small step in determining brush wear. You don't want to fly across the pond with 3 generators on the 3 engines with lower than normal brush wear. So to know what the brush wear is before you leave, you might change the 3 generators before you go, rather than knowing that you have a generator out over the pond. So these small steps in a small way actually just add to the safety aspect as well. If you can be tuned into your airplane all the time, more often than waiting for something to break and then dealing it with that also increases the safety factor.
Great.
It becomes as a consequence, yes, indeed.
I think clearly that's where the industry is going as a whole. We're all thinking the same way, because we've got the same thoughts, George, about developing programs around the data that allow us to perform different types of maintenance. And we're also thinking along the same lines with regards to an awareness of things that could be safety critical but have not yet reached their limit, and provide that to the operation, whether it be the crew or the maintenance, whoever needs to see it. So I think I think we're all kind of thinking in the same way.
Great, thank you, Nick. We'll take one more question here, and for those of you who whose questions are not being addressed here, we'll make sure that we follow up with them after. This one has to do with training. It says, how does it work for training on these health monitoring systems? In this particular case, they have a 7X Falcon that has the system. So thoughts on your training programs?
So I'll jump in on the Falcon side. When you go eventually to the maintenance initial because it's a 6X is designed around the MMS Falcon scan system, you'll get that training with the maintenance initial course. There could be additional courses specific to certain areas of the troubleshooting, but because it's a maintenance initial, that system is integrated into the airplane itself, and then that will be described within the maintenance initial course.
Thanks, Jody. George?
At Bombardier, Catherine, we have a monthly regular cycle of HMS training on our SmartLink system, and customers can sit as many times as they want for the session. And if any customer wishes to do a deep dive on any service feature, we provide them a Teams meeting where we essentially detail that training to them, and this is unlimited. They can do that whenever they see a requirement.
Thanks, George. Nick?
So we provide training for those who would have an interest in learning how to use the data. Many, I would say, initially ask for us to use it to provide them with the insights. There's definitely been an uptick on the number of people who would like to receive training. And we're actually proactively reaching out to those customers who do subscribe to this service but haven't had training for a number of years to offer them the opportunity for more training as well. Point Blair, it does provide an additional capability which can be beneficial.
Awesome. Thank you, Nick. I think in light of the time, thank you all for going a little bit over today. Blair, George, Jody, Nick, any other final thoughts to leave us with?
Just thanks for inviting us all to the roundtable. It's a good start on a philosophy that's going to be with us in the coming years. But thank you so much for inviting.
Our pleasure.
The same. Thank you for organizing again the webinar.
Yes, thank you for the invite and for organizing. Appreciate it.
Great first step.
Thank you.
And I'd just like to add, thank you three gentlemen for taking the time. You're essential to this, as you can see. And as an operator, we look forward to it. We press for it, and excited for our future.
Thank you, Blair.
Thanks, Blair. Thanks all the attendees who attended.
Yes, thank you, Blair. Thank you, George, Jody, and Nick for joining us today, and I hope everybody had very enjoyed the discussion. It's a very good first start. Thank you.
Yeah, thanks everybody for attending, and there will be another one of these coming up probably after the new year. We appreciate your participation, and we will see you all somewhere out there in the field. Fly safe, and thank you, Blair, Jody, George, Nick, so much for joining us today.
Thanks.